In a silent orbit far beyond the moon, a golden eye gazes deep into the universe. This eye belongs to the James Webb Space Telescope, humanity's most powerful observatory, launched with one mission: to unravel the mysteries of the cosmos. Developed through a global collaboration led by NASA, ESA, and CSA, JWST is not just a telescope, it is a time machine. With its 6.5-meter segmented mirror and advanced infrared instruments, it peers billions of light-years away, capturing the light of the first galaxies that formed after the Big Bang. Unlike its predecessor Hubble, which mainly observes invisible and ultraviolet light, JWST is designed to explore the universe in infrared. This allows it to see through dense clouds of gas and dust, revealing the hidden structures of galaxies, the birthplaces of stars, and the atmospheres of distant exoplanets. Its powerful optics and deep field capabilities enable astronomers to study the early universe in unprecedented detail, offering a glimpse into the era of cosmic dawn, when the first stars ignited and illuminated the dark cosmos. One of JWST's most groundbreaking discoveries came when it observed galaxies that formed just 300 million years after the Big Bang, far earlier than scientists expected. These ancient galaxies are unusually massive and well-formed, challenging current models of galaxy evolution. How did such large, structured systems form so quickly in a young universe? The data has sparked a re-evaluation of early cosmic timelines and the role of dark matter in galaxy formation. Beyond deep space, JWST is revolutionizing our understanding of exoplanets. By analyzing the light that filters through a planet's atmosphere during transit, the telescope can detect the chemical fingerprints of gases like water vapor, carbon dioxide, and even methane. In 2022, JWST detected signs of carbon-bearing molecules in the atmosphere of an exoplanet located 700 light-years away. These molecules are considered building blocks of life, and their presence could indicate the potential for habitability, or even biological processes. But perhaps the most philosophical discovery comes from JWST's wide-field surveys, which reveal a chaotic and crowded universe. What we once thought were empty stretches of space now teem with galaxies of all shapes and sizes. Gravitational lensing, the warping of light by massive galaxy clusters, helps JWST magnify these distant galaxies, revealing structures so faint and far that they defy imagination. These images aren't just beautiful, they're evidence of the vast, interconnected architecture of the universe. The telescope has also provided new insights into black holes. In several young galaxies, JWST detected supermassive black holes that appear to have formed much earlier than expected. These findings suggest that black holes and galaxies may have co-evolved from the earliest moments, feeding on each other's growth in a cosmic dance still not fully understood. Some of the light JWST captures comes from quasars, hyperactive black holes in the centers of galaxies, shedding light on the violent processes that shaped the early universe. JWST's observations are not only transforming how we see the universe, they are reshaping the very foundation of cosmic chemistry. Among its most astonishing findings is the detection of complex organic molecules, including polycyclic aromatic hydrocarbons, PAHs, in the swirling gas and dust of young star systems. These molecules, formed in the aftermath of dying stars and supernovae, are considered precursors to the basic building blocks of life. Their presence in various regions of the galaxy suggests a startling possibility, that the raw ingredients for life may not be rare or unique to Earth, but instead may be scattered across the Milky Way, embedded in the fabric of star-forming nurseries and planetary systems waiting to evolve. The telescope has also turned its golden eye inward, toward the icy moons of our solar system, and the far reaches of the Kuiper Belt, where ancient, frozen worlds silently orbit the Sun. Here, JWST has detected signs of unexpected chemical activity, from subsurface oceans on moons like Europa and Enceladus, to organic compounds on distant Kuiper Belt objects like Eris and Sedna. These findings defy the long-standing belief that such distant celestial bodies are inert, lifeless, and chemically uninteresting. Instead, they hint at a dynamic chemistry that could offer niches for life, even in the coldest and darkest corners of our solar neighborhood. But perhaps the most profound pursuit JWST has embarked upon is the quest to understand the dark universe, those mysterious forces known as dark matter and dark energy. Though invisible and undetectable through conventional means, they dominate the cosmos, comprising nearly 95% of its total content. Through precise measurements of how galaxies cluster, how cosmic structures evolve, and how light from distant galaxies bends and stretches over cosmic distances, JWST is providing clues about the invisible scaffolding of the universe. These subtle distortions, caused by the gravitational pull of dark matter, act as cosmic fingerprints, guiding astronomers in their search for an elusive truth. Might JWST be the key that unlocks the greatest mystery in modern physics, the true nature of the dark universe? As the telescope continues to gather light that has traveled for billions of years, each image, each spectrum, each faint signal ignites waves of excitement and debate among scientists. What undiscovered secrets are still embedded in these ancient photons? Will JWST be the instrument that finally helps us detect a true sign of extraterrestrial life, a biosignature in an exoplanet's atmosphere, or perhaps a chemical imbalance that can only be explained by biological processes? Could it reveal entirely new laws of physics, hidden in the early moments after the Big Bang? In every sense, the James Webb Space Telescope is more than a scientific tool, it is a storyteller of the cosmos. Its polished, hexagonal mirrors do not simply reflect starlight, they reflect our deepest hopes, our most profound questions, and our relentless drive to explore. With every observation, it pushes the boundary between the known and the unknown, between wonder and discovery. As we gaze with it into the depths of space and time, JWST reminds us that the universe is not a static, empty void, but a living, evolving, awe-inspiring expanse, filled with phenomena waiting to be uncovered. In the silence of space, JWST speaks volumes, not just about the stars and galaxies it observes, but about us, our curiosity, our ingenuity, and our never-ending quest to understand where we come from and where we're going. And in that grand narrative, it becomes clear, this telescope is not just looking outward into space, it's also holding